We're going to jump right into our next speaker. This was probably the first time that this gentleman will be following a president, although he's been a speaker many, many times. I'd like to welcome to the stage Jim White. Jim is the director of the Institute of Arctic and Alpine Research at UC Boulder. He's also the founding chair of the Environmental Studies discipline there. He's going to be speaking about the Alchemy of Carbon. And with that, I'll let you jump right in. Thank you very much, Jim.
Thank you. Is this on? Yeah, my dear mother gave me a lot of advice, and one of the pieces of advice she gave me was, Jim, never follow an American president, particularly a dead one. I really didn't think I would ever have to use that advice, but I do today. I realize that I'm going to be a letdown after listening to Teddy, but I'll try to do my best here to talk a little bit about carbon in a broader sense and try to talk about carbon in a modern sense. So let me plow ahead. I'm going to start with the take-home messages, although I missed one, I'm sorry. The carbon cycle is cool. Learn to love it. The good news is half of the CO2 emissions that we've put into the atmosphere have been taken up by the planet. And I'll give you a little more detail about that. That's good news. Without that, instead of being at 400 parts per million CO2 today, we'd be at 500 parts per million CO2 today. All right? The bad news is we're not sure if this is going to continue. So we have to understand what the planet has been doing and whether or not that can continue. And it's even worse because that carbon doesn't go away. It goes into places where it can come back out to the atmosphere. And that makes it very difficult for us to manage carbon. If we were to, for example, stop burning carbon fuels today, CO2 levels would not drop because the ocean would start to give back to the atmosphere some of that carbon that it's already absorbed. So it's a cycle, in other words. I'm also going to show you a slide right at the end. I'd like you to learn to think in CO2 units. We hear about temperature a lot. Temperature is... I'm a climatologist. I study two things. I study paleoclimate using ice cores, and I study the carbon cycle. I chose those topics 30-something years ago, and quite frankly, I thought that by the time I reached halfway through my career, we would have a carbon policy, and I could move on to something new and exciting. And I totally screwed that up, obviously, because we haven't done anything about that. And I'm still a climate scientist, and I'm still a carbon scientist. But what's important, I think, to recognize is that it's probably a lot better to think about the world in terms of CO2 than to think about the world in terms of temperature. And I'll give you an example of that. Okay, so this is the carbon cycle in a pictorial nutshell. About 91% of the carbon we put in the atmosphere is from fossil fuels, coal, oil, and natural gas. About 9% of that is from deforestation. And I want to pause for a moment because deforestation is something that I thought, many of us thought, 20 years ago we had faced and solved. And no, that we have not faced and solved either. We are still cutting down forests today with gusto. So roughly 10% of the CO2 we put in the atmosphere is through deforestation. All right? Now, where does that stuff go? About half of it, in rough terms, stays in the atmosphere. It's 44% on this slide, but you can think in rough terms. Roughly half of it stays in the atmosphere. About a quarter of it goes into land plants. On this slide, it's 31%. But let's use easy numbers here. And about a quarter of it goes into the ocean. All right? The ocean's got most of the carbon in the carbon system, and the ocean tells the atmosphere what to do. So when the atmosphere gets out of control, the ocean says, you got to give me some of that. That's the way that works. Land plants sucking up CO2 is a bit of a conundrum to those of us who study the carbon cycle, and it's a bit of a remarkable conundrum. And I'm going to show you a few sciencey type pictures here, and this is one of them. Focus on the top of that. The carbon emissions have been going up and up and up and up, and I'll show you more detail of that in a minute. But we've been emitting more and more carbon as time goes by. Today we emit more carbon than we did last year and the year before, et cetera, which is important because we haven't turned that over, as we heard earlier today. Atmospheric emissions are in the middle blue line there, and the Earth uptake is in the black line. As we've added more and more and more carbon every year, the Earth has taken up more and more and more carbon. That's unexpected. It's expected for the ocean to do it, but it's not expected for land plants to do that. Land plants have been taking up more and more carbon even though we've been cutting down forests. Now, that's got to have a logical end to it. because we're going to run out of forests. And we're going to run out of the ability of forests to suck this stuff up. And when forests quit sucking that up, that blue line, instead of lagging behind the emissions line, is going to start racing up towards the emissions line. Right? So this is an important key part of the carbon cycle that I think we need to understand. The planet has been doing us a great deal of work and a big favor for us, and that we can't expect that favor to continue. All right. Second point I want to make about carbon cycle starts with this graph. This is CO2 emissions as measured by reported burning of coal, oil, and natural gas. Reported burning from all countries around the world. When Kyoto was ratified, we didn't ratify it, when it was passed, one of the things we had to do, everybody had to do, is say, how much emissions have you burned? Now, interestingly, over the last few years, the amount of emissions emitted to the atmosphere, according to the reporting, has leveled off. Now, that's interesting for this reason. All right? This is, again, in black here, the amount of CO2 produced to the atmosphere every year, as reported by countries around the world. That number always goes up in the past, except for when we had financial crises. The oil crisis in the 1970s, when OPEC was formed, the U.S. savings and loan crisis, which was a big deal back in the 1980s, the collapse of the former Soviet Union, the Asian financial crisis, the 2008-9 crisis, which, by the way, didn't hit the rest of the world nearly as hard as it hit us. And as you note, the recent tailing off doesn't coincide with a financial crisis. If it's true, it's the first time that this has happened. And a lot of people are very excited about this. Now, here's the problem with this. All right? This is the amount of CO2 in the atmosphere. And I'm showing you 4 sites. It's measured at 50, 60, 70 sites around the world. I'm showing you 4 of them, Barrow, Mauna Loa, Samoa, and South Pole. That's continuing to go up. There is no downturn after 2015 in the amount of CO2 in the atmosphere. It's possible that we've been burning less and less CO2, and CO2 continues to rise because of the way the carbon cycle functions. It's not likely, but it's possible. It is more likely, probably, that those people who report burning have not been doing it as well as they perhaps thought they were or perhaps should have. Right? So this is a very valuable lesson to us, and I'll bounce back to the previous slide. Is the amount of CO2 we're producing in the atmosphere going down or leveling off, or is it not leveling off? That's a really important piece of information. And the atmosphere is telling us, if you think it is, maybe you ought to rethink that. Okay? This tells us that we need to monitor. All right? Now I'm going to put on my carbon cycle hat. I've worked with NOAA for about 30 years, National Oceanic and Atmospheric Administration. I measure something called carbon-13 in CO2. I've done that with them for a long period of time. I've watched since 2007 as NOAA has struggled with sequestration, and now with the budgets that the Trump administration has put forward, repeatedly threatening to cut. They've already lost 27% of their purchasing power since 2007. NOAA has, the carbon cycle group. So the global monitoring, which the United States does so well, has already been cut quite a bit. And now the suggestion from the White House is that's cut another 27%. I can tell you that is going to cripple our ability to monitor CO2 in the atmosphere. This is something we need to pay attention to. Okay? There is another piece of information here that I want to convey to you, and that is that it's not just enough to measure the CO2 in the atmosphere. We can go beyond that. We can get smart about what we measure out of the CO2 in the atmosphere. All right, so the first point here is monitor, monitor, monitor. And I want to point out it works. The CTBTO is a badly acronymed organization. This is basically the organization that puts in seismometers around the world and measures whether or not people are cheating in terms of setting off underground nuclear tests. This was established between the United States and the former Soviet Union a long time ago, and it's been a network of monitor, monitor, monitor. Remember, Ronald Reagan uttered the famous phrase, trust but verify. All right? The verification came because there were seismologists who were listening to the ground. And if you wanted to shoot off a nuclear weapon, we know about it. It's how we know, for example, today when North Korea shoots off a nuclear weapon. We know it happens. You can't hide these things. Monitoring works. All right? We can also monitor CO2 in the atmosphere, but we can also measure something called carbon-14. So there's various flavors of carbon in the carbon cycle. Most carbon is carbon-12. It's a stable molecule, lasts forever, basically. Carbon-14 is a radioactive form of carbon. Because the half-life of radiocarbon is only around 5,500 years, fossil fuel, coal, oil, and natural gas, being millions of years old, has no carbon-14 in it. So when the plants make CO2 go in and out, when the ocean makes CO2 go in and out, it carries with it the signature of this modern carbon-14. When we burn fossil fuels, it's a big red flag of this is CO2 that has no carbon-14 in it. It's a beautiful way to measure human emissions of CO2. We don't have to argue about whether or not this is land plants or whether or not it's the ocean. We can measure this directly, all right? And this next slide shows that. On the left is CO2 breathing of the planet in July of 2010, showing the big uptake. The blue here is lower levels of CO2. That's biosphere, sucking CO2 out of the atmosphere in July of 2010. Right? On the right-hand side is just the carbon-14 that's measured. And the carbon-14, as you can see in the United States, picks up the industrial areas of the eastern United States, and it picks up California, the 6th largest economy in the world, very well, because it is just tracing coal, oil, and natural gas emissions. Right? We've tried since 2008 to get the equipment to measure this. And of course, Congress and the Obama administration locked horns, and nothing got through that mess. We have another request in to the White House to include this in the budget. That went nowhere. I don't think that this Congress is going to pass this either. We've got the tools to measure human emissions of CO2, and we're not doing it. We are purposefully blinding ourselves to levels of CO2 in the atmosphere that we emit. And there's really no reason to do it. All right. Now I want to finish up on this slide. And it's a little bit complicated, but there's a really important point here. At the top, you see atmospheric CO2 in its log units. And the bottom here is log of. The reason why we use log of CO2 because that's the forcing of CO2. It's the climate forcing. Sea level is on the left axis. First, I want to point out that sea level goes from a negative 120 meters to plus 80 meters, 200 meters. 200 meters is a lot of meters. Right? This is the relationship between CO2 on our planet as measured going back back 40 million years or so, and the amount of CO2 in the atmosphere. And you see some things on here that are really important. One is that the cross line here is pre-industrial. That's 280 parts per million CO2, sea level of where it was in the 1950s or something like that. We're at 400 parts per million CO2 today. The planet tells us very clearly that with the CO2 we have in the atmosphere today, we should expect something in the neighborhood of 14 to 15 meters higher sea level. That's 46 feet of sea level. And it's not a question of whether that water is going to come. It's a question of how rapidly it comes. Whether or not it takes 100 years, 200 years, 300 years, that's the question that glaciologists are trying to answer today. Not whether or not it will happen, but when it happens. We heard about Hampton Roads earlier today. You got to raise the docks up. You got to raise them up and up and up and up. For the next couple hundred years, we're going to be raising the docks up. Okay. The other really important point on here is that you can tell on here when does the planet get warm enough that you can't have an Antarctica, that you can't have a Greenland. And that's when sea level goes up to about 75 meters higher than today, which I calculated and wrote it down. That's 250 feet. Go down to the ocean and look up. I can't visualize 250 feet, but it's a hell of a lot of feet. All right? That's where the ocean level is going to be when Antarctica and when Greenland melt. All right? Now, the planet tells us that that happens somewhere in the neighborhood of 600 to 700 parts per million CO2. We're at 400 today. We burned more fossil fuels last year than we ever have. Can we make 600? Hell yeah, we can do it. Will we do it? Hell no. I don't want to see that happen. I know you don't want to see that happen. And this is something we have absolutely got to put the brakes on. We've got to turn that corner. We've got to start bringing emissions down. Because when you get closer and closer to 600 parts per million, you're on a planet that is too warm for Antarctica. All right? So, did I miss anything? Oh, Jody wanted me to say, no. No, I'm 4 seconds and I'm done. All right. Thank you all for listening. And Keep doing what you're doing.